Hi, my name is Mutambuze and I'm presenting traffic monitoring using simple machine learning models. So, traffic monitoring is crucial for urban management and planning, of course. And the objective of this study is to enhance traffic monitoring and accuracy using machine learning and simple models. So the study investigates multiple traditional machine learning models and, of course, combines them using simple methods to improve the classification and detection improvement. So, so we are evaluating various traditional machine learning models and, of course, combining them to come up with a better performance. So, the data set that we have, it comprises of over 16,000 frames that, of course, we generated, and we extracted this from video footage that was captured during the daytime. And of course, we used annotated using the YOLO 1.1 version and formatted it via the CPAT. So the annotations included identifying the vehicles, such as the lorries, the cyclists, or the border borders, and of course the buses. So this is the distribution of the classes. So like I said, the classes are used with three classes: one for the lorries, one for the cyclists, and one for the buses. And of course, we had more cyclists than the buses, and then of course the lorries. So the lorries are important for monitoring the improvement of heavy goods and of course understanding their impact on traffic flow. Then of course our cyclists, mainly the border borders, these ones are significant in urban areas where motorists or motorcycles are prevalent and affect road safety and traffic dynamics. Then the buses are essential for managing, of course, public transport systems and, of course, understanding the commuter flow congestion. Yes. So feature extraction. So during the process of feature extraction, we used color histograms where we are representing the color distribution within the particular image. Then, of course, we focused on the region of interest analysis, focusing on specific parts of an image where the vehicles were located. So, of course, feature extraction is crucial for improving model accuracy and, of course, by providing meaningful inputs. Yes, meaningful inputs data. So, uh, the region of interest analysis, like I said, its main focus is extracting features from specific regions. And so it extracts particular features from specific regions where our vehicles will be located, and of course, it helps reduce noise and improving detection accuracy. So the machine learning models, the architecture for the base architecture for the base models that we use, and of course, moving to the examples, that's the architecture that we have where we do process the data set, yes, pre-process, and of course, we annotate using YOLO, then we do feature extraction. So we do feature extraction. Then, of course, after we feed this into the base classifiers, which include the KNN, the SVM, the decision tree, random forest gradient boosting, and boost logistical regression, FYs, and then neural networks. Yes, yes. So, yes. So, from this, that's when we move on to the we will move into ensembles. Yes, so a brief explanation of the KNN. So we know that KNN is just it is simple, and of course it is exact-based learning algorithm that classifies a sample based on majority class among its nearest neighbors. Then the SVM finds, of course, the optimal hyperplane that separates different classes in feature separation. The decision tree, we know it splits the data based on feature values, creating a tree-like model. Then the RF, that's a random tree, is that Swanzani symbol of the decision tree combining their outputs, and of course improving accuracy and robustness. The kid B builds sequential models to correct errors made by by previous ones. Yes. So the NNs consist of layers of interconnected nodes. Of course, ones are capable of capturing complex pattern in data. So this is the architecture that we use to generate the predictions that we get from these base models individually. Then, so of course we have the assembles. Yes, so the assembles, these ones, assembles, assemble learning combines multiple base models to improve the overall performance. And the assembles used in this project are, of course, voting classifiers. Yes, voting classifier, that is voting, which combines the predictions from the multiple models by leveraging their individual strength and, of course, mitigating their weaknesses. So it averages. This model averages them to make a final prediction. So that is the assembles. So the first assemble was combining the KNNs, then the support vector machines, and of course the decision trees. Yes. So here we are using we used the soft voting to average the predicted probabilities and of course make the final prediction. So like you can see the architecture, that is exactly how the flow was. So soft voting averages the predicted probabilities from each base model and of course uses this to determine the final prediction. Then also in December 2, we're combining the random forest, the gradient boosting, and of course the ADA, and of course we still use the soft voting to average the predicted probabilities and make a final prediction. So we know the random forest can help us reduce overfitting. The gradient boosting it iteratively improves performance, and of course the FB focuses on difficult to classify instances. Yes, so that is the architecture for the second ensemble. Then the third ensemble was combining the logistical regression, and we know that is good for linear classifications, and the naive Bayes, which is the probabilistic classifier. Then the neural network for capturing complex patterns, and we're still using the voting classifier to average the inputs from all the rest into a final output. So the results from the individual based models, and of course the ensembles, as you can see, we're going to discuss them further, but you can all see that ensemble 2 has the highest AUC, ROC AUC. The ensembles perform better than the individual models. Yes, this of course shows us that when you combine, you get a better output from the model. Then so the evaluation metrics. So the models were evaluated using the following matrices, which is the precision, the accuracy, positive predictions, the recall, which are to identify positive instances, the F1 score, the Harmon mean of precision and recall, and then the area under the ROC curve, was indicating the model's ability to distinguish between the classes. And you can see the performance of them, and you see that the assembles are still performing better than the individual models. So the results, we can see from the individual assemble models that the assembles, of course, generally outperformed the individual models. Assemble 3 had it achieved the highest ROC AUC value of 96%. The precision, recall, and F1 scores were also highly significant. They were higher for the assembles. Yes. Then the confusion matrix. We generated the confusion matrix also as well. And the coefficient matrix visualizes the performance of each model. They show the true positives, the true negatives, false positives, and the false negatives. Yes, and from this, we realize that, of course, the best overall performance was the sample 2 with a perfect prediction of class 1 and the highest overall accuracy that demonstrated the best performance among the three. So it balanced the performance. In balancing performance, sample 3 showed balanced performance with relatively few errors across all the classes. Then the strength in class 1, all the three samples performed best, predicting class 1, which is a cycle less likely due to the high number of instances within the data set. So in conclusion, the ensemble model significantly improved traffic model accuracy. Software voting in ensembles method effectively combines the strength and individual models. And of course, importance, enhancing traffic monitoring system can aid in better urban management. And for the future works we explore, we need to explore more advanced ensemble methods and real-time processing capabilities. So I want to extend my sincere appreciation to Dr. Rose and Achibule for the exceptional guidance and the support during this project.